Imagine if Earth had an edge, like the edge of a table. It's an interesting thought, even though we've discussed it before. There's something captivating about the idea of a flat Earth, especially when we imagine a solar eclipse on this unique surface. Picture trees growing diagonally, defying gravity's pull. And there's even talk of a massive ice wall at the perimeter, guarded, of course, by NASA in this imaginative scenario. The creativity of flat Earth proponents is truly something to marvel at. But what if they were onto something? Recap. Just in case you're not up to date with the latest from the flat Earth enthusiasts, let's quickly go over what they're talking about. For centuries, people believed that Earth was flat, the center of the universe. Then came Nicholas Copernicus with his revolutionary idea. He proposed that Earth wasn't flat, and it didn't sit at the center of everything. Through observations, he realized that our planet actually orbits the Sun. Fast forward 500 years, and there are still people worldwide who firmly believe in a flat Earth. Effects of a flat Earth. Ever wondered why planets are round? One word: gravity. Gravity pulls matter together from all sides equally, shaping it into a sphere. However, this wouldn't be the case if Earth were flat. Those who argue against the round Earth idea suggest there's no such thing as gravity. They propose that what we perceive as gravity is actually a mysterious force constantly pushing the flat Earth upwards, creating the sensation of being pulled downward. But there's a catch: you can't keep accelerating forever. Eventually, you'd hit a point where the speed becomes too much. Imagine feeling like an overcooked pancake. Now, let's explore some real science. On a flat Earth, gravity would still exist, but it would behave in a strange way. The center of gravity would be right in the middle. Everything on and around Earth would be drawn toward this central point. As you move away from the center, the gravitational pull would strengthen. Eventually, it would start pulling you downward, requiring you to climb. This unique gravity pattern would prevent you from walking to the edge of a flat Earth. The gravitational force around the edge would be so strong that getting there would be nearly impossible. You'd likely never witness the impressive 150-foot tall ice wall known as Antarctica, supposedly surrounding the Earth's edge. Exploring what's on the other side would be off-limits, but at least you wouldn't fall off. Other effects of this peculiar gravity would emerge. Objects closer to the edge would fall sideways instead of straight down. Trees might grow diagonally across most of the flat Earth, resisting the gravitational pull. Precipitation like rain, snow, and hail would converge toward the center, forming a buildup. Even the oceans would be drawn toward the center, creating a single massive ocean in the middle. Now let's talk about air pressure. On a flat Earth, gravity would pull an excessive amount of air toward the central point, leaving the outer regions with very little air pressure. This would be problematic for people living in places like a flat Earth Australia. They wouldn't have enough breathable oxygen. Meanwhile, those near the center would experience crushing air pressure due to the weight of the atmosphere. But this situation wouldn't last long. Unlike our round Earth, a flat Earth wouldn't have a protective magnetic field generated by the core's movements. This lack of a magnetic field would cause our atmosphere to gradually escape into space. As a result, we'd be exposed to harmful solar radiation, leading to health issues like cancer and DNA damage. Breathing comfortably would become impossible due to the disappearing atmosphere. So, if you ever find yourself on a flat Earth, make sure to have a reliable life support system handy. Now let's address a common question: what would orbit a flat Earth? Every flat Earth advocate insists that the Sun and the Moon circle above a pancake-shaped Earth, acting as massive spotlights. But let's apply some scientific reasoning to this notion. If the Sun behaved like a spotlight, you'd see it from all points on Earth, even if it didn't shine directly on you. Imagine it being like those scenes from alien abduction stories. Where did they come up with that idea? In this scenario, day and night wouldn't alternate as they do on our round Earth. Our sleep schedules would be quite chaotic. To fix this, let's adjust the system. If the Sun orbited the flat Earth in a specific way, we could have alternating days and nights. When the Sun rises, daylight would spread across the entire planet. As the Sun sets, darkness would encompass the Earth. Time zones and seasons wouldn't exist in this scenario, but you could still disrupt your schedule by staying up late to watch worldview theory videos. Now, consider the size of the Sun. If the Sun maintained its enormous size while orbiting a flat Earth, it would be dangerously close, potentially causing the planet to burn up. On the other hand, if the Sun were much smaller, we'd freeze due to the flat Earth's larger surface area compared to our round Earth. This would result in receiving only a fraction of the energy needed to support life. The lunar eclipse. Here's something we haven't touched on yet: the lunar eclipse. Flat Earth proponents propose the existence of an anti-moon responsible for these events. On our round Earth, lunar eclipses occur when Earth comes between the Sun and the Moon. If the flat Earth scenario were accurate, lunar eclipses might look like this, requiring precise alignment. If the flat Earth theory turned out to be true, and the globe we know was indeed manipulated, leading to rigged GPS devices for financial gain, it could spark discussions about other conspiracy theories. Unfortunately, many individuals, including flat Earth believers, struggle with cognitive dissonance when their thoughts and beliefs don't align with reality. We're bombarded with pseudo-evidence that can support any theory, even if it lacks logical consistency. Imagine if Copernicus had spent hours watching flat Earth conspiracy videos on YouTube. Even he might have questioned his own groundbreaking ideas. And as for a donut-shaped Earth? Well, that's a topic for another conversation about alternative worldviews.
Born on February 15, 1564, in Pisa, Italy, Galileo Galilei displayed an early aptitude for mathematics and the natural sciences. He attended the University of Pisa, where he began his scientific journey. In 1609, Galileo developed a powerful telescope and made groundbreaking astronomical observations. He discovered mountains on the Moon, moons orbiting Jupiter, and the phases of Venus, supporting the heliocentric model. Galileo's observations provided compelling evidence for the heliocentric model proposed by Copernicus, which stated that the Earth orbited the Sun. Galileo's support for heliocentrism challenged the geocentric views held by the Catholic Church. In 1616, he faced opposition from the Church and was ordered not to defend the heliocentric model. In 1632, Galileo published his most famous work, Dialogue, which presented arguments for heliocentrism. This resulted in further confrontation with the Church. In 1633, Galileo was tried by the Inquisition and forced to recant his heliocentric views under threat of imprisonment. He spent the rest of his life under house arrest. Galileo's work in mechanics and the study of motion laid the foundation for Newtonian physics and contributed to the development of classical mechanics. Despite challenges, Galileo's contributions to astronomy and physics revolutionized scientific thought. His methods of observation and experimentation remain fundamental in scientific inquiry. Galileo's willingness to challenge prevailing beliefs and explore the cosmos set the stage for the scientific revolution, inspiring generations of scientists and thinkers. Galileo Galilei passed away on January 8, 1642, in Arcetri, Italy, leaving a lasting legacy.
Legend that will last a lunchtime.
Now we look over their heels, say, oh, I believe it. Yes, they. Well, suddenly, I'm not the man I used to be. There's a shadow hanging over me, though I believe it. Yes, they. Why she had to go, I don't know, she wouldn't say. I said something wrong, no. Never knew what to say. Oh, I believe it, yeah, yeah, yeah.
Do you guys believe like the Earth is flat, or like the Earth is round?
Have you ever been, dude? Have you ever been to the edge of the Earth? Have you ever seen? Have you ever been in space? Don't think so. The Earth is flat. You know, actually, it is, Wayne, like a little tiny like crater. That's why it's flat right there.
Televisions by the people.
the Earth is flat, how do you explain time zones?
So if it's a close sun, it would be kind of like a spotlight. The time zones work because that local light, just kind of like a flashlight, doesn't light up the whole circle. It only lights up a certain part of the circle.
I'm curious what the explanation is for gravity and things like the Coriolis effect.
Well, gravity's still technically a theory. We know that there's an up and a down. As far as Coriolis, I was in the military and I've shot weapons, and we were never once taught to account for Coriolis.
What kind of weapons, if you don't mind me asking? Like ICBMs?
Well, when I was in the military, we shot M16s, and the railgun is a question because it can shoot 100 miles, and it's a line of sight weapon. So 100 miles using the curvature of the Earth, it just doesn't make sense that they'd be able to hit the target.
On this day in space. On December 30th, 1930, the Earth's curvature was photographed for the first time. This photo was taken by Lieutenant Colonel Albert William Stevens, who was an officer in the U.S. Army Corps and an aerial photographer. He also happened to be a balloonist, and he once broke a world record for a high-altitude balloon flight. Stevens took this photo while flying an airplane over South America. He used infrared-sensitive film that worked well for long-distance aerial shots in which the subject was obscured by things like haze. The mountains he was photographing were more than 300 miles away, and he couldn't see them with his own eyes, but his camera was sensitive enough. The photo was the first visual proof that our planet is in fact round. And that's what happened on this day in space.
This is a challenge. Introducing the Flat Earth Challenge. You may not know it, but someone close to you is one of the millions of people that now believes the Earth is flat. It's hard for them to admit it because of social shame, but they know it's true and logical because they've looked into it extensively.
Earth, throughout its life, even when it formed, it was spinning, and officially it's an oblate spheroid. It's slightly wider below the equator than above the equator. But it's like pear-shaped. It's like pear-shaped. It's like pear-shaped.
This video is in response to the many globe propagandists who demand that I show a picture of the edge of the flat Earth. I'm going to prove in this video that independent travel is not allowed under the Antarctic Treaty System. That fact alone should cause any thinking person to begin questioning our official models, because something big is being hidden from we, the plebeians, and we're not talking about penguins. For most flat earthers, based on the information that we can reasonably gather, Antarctica constitutes the outer rim of the known world. In other words, Antarctica is likely the shoreline to all of the world's oceans. This is the 60th south parallel on a potential flat Earth azimuthal equidistant map. It seems that Antarctica constitutes the circular shore of the known world. So, demanding that I take a picture of a possible edge of the Earth, if any, requires me to not only travel below the 60th south parallel, represented by the circle, but also to cross the entire breadth of Antarctica. Or whether Antarctica is indeed the shoreline of the known world, I don't know the answer. Flat earthers don't have a government budget to spend $1 billion to hire hundreds of cartographers and fleets of boats and planes to map the entire world. But even if flat earthers had the money, we would still run into the Antarctic problem, which is the point of this video. So, what is the Antarctic problem? It is the fact that independent travel is not allowed below the 60th south parallel in any reasonable manner to make any determination But, as I will describe in this video, I suspect that Antarctica is the shoreline, circumscribing the known world, due to the unbelievable restrictions placed on travel there. Do you really think it's because of penguins? The Antarctic Treaty was executed in 1959 and has been in place ever since. Think about it. No country had any real alleged concerns about the environment at that time. One of the more interesting facts is that the Soviet Union also ratified the treaty, and did so from the beginning on December 1st, 1959. Do you really think the Soviets were truly concerned about the penguins and the fragile Antarctic environment? In other words, America, the USSR, and the rest of the major countries of the world remain partners in generally closing Antarctica throughout most of the so-called fake space race, the Cuban Missile Crisis of 1962. As I was preparing this video, I found something else that's interesting. Out of all the flags of all the countries across the Earth, can you guess which one only shows a map of the country as the emblem of the country? You guessed it. Only one. Antarctica. Yeah, the one country they want you to know the shape of. Let me make this clear from the beginning. Travel to Antarctica is more difficult than travel to a military base. I'm not talking about going to the visitor center along the edge of Antarctica. I'm talking about a real trek, pointed directly south across the entire 3,400-mile breadth of Antarctica and back again to determine whether Antarctica circumscribes the known world and to possibly determine whether there's an edge, a dome, or whatever, and then take a picture of it. I'm talking about repeating the trek of Admiral Byrd and discovering that area as big as the United States that has never been seen by a human being on the other side of the South Pole, full of minerals and such just waiting to be explored.
But strangely enough, there is left in the world today an area as big as the United States that's never been seen by a human being. And that's beyond the pole, on the other side of the South Pole, from Middle America. And I think it's quite astonishing that there should be an area as big as that unexplored.
Okay, let's get started with our theoretical trip. So what is required to trek across the entire breadth of Antarctica? Now, I'm in the United States, and so we're going to examine it from the position of a slave of the U.S. But the rules are going to be the same for all 53 signatory countries of the Antarctic Treaty, and everyone else, since these countries all enforce the same provisions. To begin with, we need to understand that anything below the 60th south parallel is referred to as the Antarctic Treaty Area. What does that mean? That means I'm generally not allowed within hundreds of miles of Antarctica, from approximately 400 to 900 miles, without obtaining a permit to do so. Now, the U.S. government has recorded that some sailors have seen the mountain ranges of Antarctica at 300 miles distance while sailing. Of course, 300 miles should be impossible on the globe with a curvature drop of 11.4 miles, but the 60th parallel is between 400 and 900 miles away from the shoreline of Antarctica. Even under a flat Earth, that's a lot of lower atmosphere to see through. In other words, I can't even see Antarctica from the ocean without first obtaining a permit from the U.S. State Department, or whatever department that controls that in your country. Taking a trip to the 60th south parallel isn't going to accomplish anything, and so we're stuck with getting a government permit. So let's go through the steps to obtaining a permit from the U.S. State Department. This is the handbook of the Antarctic Treaty System. These are the rules that govern all signatories to the treaty. Most importantly, we're going to look at the rules governing non-governmental activities located here, and some of the rules regarding the protection of the environment located here. Now, as a U.S. slave, this is the first form you'll have to submit to get approved to travel to Antarctica. The form itself seems rather innocuous until you understand exactly what is involved in the application process. In summary, Antarctica is treated as a giant natural reserve. Like a military base, all activities and pathways in Antarctica must be approved. This is unlike any other area in the world, except maybe a place like North Korea. So, when I say that no independent travel is allowed below the 60th south parallel, I'm stating an admitted fact well recorded as international law. If you visit Russia, with a Russian visa for example, are you limited to one particular neighborhood and certain pathways? No one is just allowed to travel around Antarctica. All of your activities, vehicles, and pathways must be approved.
Connections made every day on T-Mobile's network. From calls, texts, videos, and pictures to GIFs and emojis. That's a lot of cat videos. To meet demand, T-Mobile is constantly adjusting and expanding our national network. We keep your mobile world moving. It takes an endless balance of hardware, software, antennas, radios, and indoor and outdoor technologies. Wireless depends on wired ground-based infrastructure to connect customers. How does it work? Well, imagine watering a landscape. You spray water so it properly saturates the ground, flowers, trees, and shrubs. However, you wouldn't use the same pressure to water a large field as you would a delicate flower garden, and a brief mist does nothing for an evergreen or oak tree. Like watering a landscape, robust wireless networks must use the right technologies and antennas for the best wireless connectivity, depending on the carrier's needs and local conditions. Large macro antennas can distribute a signal far along roadways and adjoining neighborhoods. However, in populated areas, that same signal might have difficulty overlapping with the signal from the adjacent cell site. Radio signals that are too weak or too strong can result in bad coverage, dropped calls, or poor clarity. The same is true with a lawn sprinkler. Dry patches happen when a sprinkler misses part of the grass. T-Mobile's challenge? Our always mobile customers have skyrocketing demands. One way we're meeting this demand is with smaller, lower power, and more numerous antennas and radios, small cells.
We have to take in consideration the noise that's in the network. A good example of this is that when you go to a coffee shop and you're the first one in there, you clearly can hear anybody that's actually in that coffee shop. So as the coffee shop starts to fill up, the noise begins to rise. And the only way you can actually enjoy the conversation now with individuals is actually to get closer together and have that conversation so it's quick, it's clean, without interruption. In the network, it's the same principle. We actually have to get the devices closer to the customer so you get good throughput and quality of service.
As your network grow and you need more and more capacity, now you need to come up with other solutions that can strategically put the capacity where you need it. That's where the small cell comes in.
Even though their footprint may be smaller than a typical macro site, small cells do provide coverage in areas because they are closer to the people that are actually holding those smartphones.
Small cells are typically deployed in dense urban areas where we have a lot of foot traffic, outdoor shopping areas, indoor and outdoor venues.
The antennas are very small. They're probably the size of a toaster. You can actually put the antennas on an existing utility pole without replacing those existing utility poles. Or existing fixtures in the street, you can actually attach those antennas.
You may not notice them due to their slim form factor, but thanks to low-power small cells, you can enjoy uninterrupted wireless services where you live, work, and play. Even for retail shops, small cells can be extremely effective. Businesses of all sizes depend on mobile coverage.
Mobile technology is absolutely an advantage in our community for business development. We try very hard to attract new business and we try to retain existing business. And one of the main issues is connectivity. To the extent we can provide the best connectivity, we're going to keep new business and I'm going to keep cutting ribbons.
Our cities and communities rely on a wireless network for convenience, safety, and quality of life.
In every municipality, the residents want connectivity. They want calls that aren't dropped. They want to make sure that wherever they go, all their tools are going to work.
Small cells actually play a great role on those residential areas.
Low-power small cells bring reliable coverage to large campuses, venues, and sporting events. Wherever crowds congregate and people want to communicate. Small cells will also work well with 5G.
5G is going to allow us to do many great things.
Like Internet of Things, when you're starting to look to provide connectivity to cars, to refrigerators, to even the washer and dryer at home.
Uploads and downloads faster. It will be more like a real-time speed. They're going to be able to see stream videos faster.
Smart homes and smart cities and autonomous vehicles.
So 5G brings together a lot of what we use every single day.
For business owners, for families, friends, and everyday conveniences. Living in our connected world, you need a mobile device and the robust network technologies that make connectivity possible.
Okay, got another little demonstration for you. We're going to experiment with compasses. Compasses. Here we go. Circumnavigation of the Earth. As you see, this compass will point at the North Pole. And as you circumnavigate Around the world, sailing, flying, whatever you choose. Compass always points at the North Pole. Either direction. Where are we at? Circumnavigation. Well, try it up here on a globe. It works up here. I'll show you here. It's working up here, right in the Antarctic Circle, but as soon as we get down here, not so much anymore. Spin the sucker. And yeah, doesn't work so well until you get up to the Antarctic Circle, or Arctic Circle I should say, where you're holding it flat. How do you hold the compass? Flat. Let's say this is another win for the flatties.
This first one is from Luke 6 Hill, and he wants to know your thoughts on, is the Earth flat?
Ooh. I mean, I think it is. I feel like it is. We walking flat. So how's it round? Like, I don't get it. It's a tricky question though, but I think it's flat.
Wait, so you've listened to the theories and everything from the NBA players who share this theory?
Yeah, he made some tremendous. He just made me feel good about that. I feel like it's really flat. I think it is. There's no way we can walk around.
So what do you say to the counterpoints that science says that the Earth is not flat?
I don't really know what to say to them.
This is Christopher Columbus and goes for a flat world.
I know, but really, you're such a dreamer. You'll go out there and you'll sail right off the edge of the world.
Oh, bravo! Hey, was that moving? Was that a great bet? Have your permission to sail?
Have you had your shot?
A little bit yourself there.
I tell you, the world is flat, and that's that.
It's round as your hat.
It's flat as your head.
It's round.
It's flat. Flat.
A classic. Enjoy. Take a look. Were you addressing me? Were you addressing me?
I tell you, the world is flat, and that's that.
It's round as your hat.
It's flat as your head.
Receive the shock of...
Were you addressing me? Were you addressing me? Were you addressing me? Well, there's no one else here, is there? Unless I'm sadly mistaken. There's no one else here. Ooh, you made me hurt my neck.
42.
Okay.
Shall I tell you why we brought you here?
What's your nozzle efficiency? With a traditional combustion chamber, you can get to, but no actual rockets.
Where the artist wants three-dimensional, solid-looking images. To date, the only alternative to making a model has been film animation. And the reason that the animation takes so long is that hundreds of separate pictures like this have to be drawn and photographed one by one to make even that short-moving sequence. Bottom line here, first, then it appears at the top and I become a star of Australian television. By constantly recording the lines and replaying them at the wrong times, all these effects can be achieved.
Ladies and gentlemen. Canned as only McCann can.
The President of the United States and a new Congress will depart from the Flat Earth Society attitudes on science of the and come together with ethical principles supporting the Flat Earth.
Masonic liars get stuffed.
Grapple vision, yeah.
I thought it was just a joke when Brian first mentioned it. I thought he was just like teasing him. But apparently not. AJ said, you know, there are things I've read. There are things I've read. There are things out there, he said.
I have a cold. I'm kind of dumb.
Hey, AJ, do you want to talk about how you think the Earth is flat?
Do you want to talk about how your feet are flat? I'm just saying there's some stuff about it.
He's a flat earther.
I don't think you can handle it.
I don't think you can handle it. Yeah.
How do we take science and how do we make sure that that stays relevant and expanding?
So what we need is a reality show where you get someone who's in denial of science, then overnight you take everything out of their life that is science-enabled. Okay? Where's my cell phone? Sorry, that uses GPS satellites. It's a space program, and I think Earth is flat. Okay, so you don't get to fly in an airplane because you might fly off the edge of the Earth. But you have to put a limit to that because there's a level at which you can take away science where they would just be dead. They would have died in childbirth.
How do we take science and how do we make sure that that stays relevant and expanding?
So what we need is a reality show where you get someone who's in denial of science, then overnight you take everything out of their life that is science-enabled. Okay? Where's my cell phone? Sorry, that uses GPS satellites. It's a space program, and I think Earth is flat. Okay, so you don't get to fly in an airplane because you might fly off the edge of the Earth. But you have to put a limit to that because there's a level at which you can take away science where they would just be dead. They would have died in childbirth.
Make no mistakes in the legalities. But I welcome you here, and I'm glad that you're here.
Rock and roll, you know. Anyway, before the Beatles came along, I mean, people have been trying to stamp out rock and roll since it started.
Why do you think that is? What
For months, the
Neil, I gotta say, you're totally blowing my mind right now.
The Earth looks flat because, one, two, any curvature at all. It's a fundamental fact of calculus and non-Euclidean geometry. Any curvature at all.
Where is the curvature? Where?
Those challenges are yours. In many fields, not the least of which is space, because there lies human destiny.
Hey, the drink the astronauts took to the moon.
Astronauts to the moon.
Principal elements, leaving Earth, navigating in space, and descending to a planet unencumbered with runways and traffic controls.
The world is flat. Grand Deer State Park. This is from Joshua the Wiki. And what you're seeing here is a mirage. Typically, you would not be able to see this relationship. So we talked about this last night. Conditions are right on the lake. Perhaps seeing the rock of the Chicago skyline.
Who supported the geocentric model? The geocentric model was supported by many ancient Greek astronomers, including Aristotle and Ptolemy. They believed that the Earth was at the center of the universe, with the Sun, Moon, and other planets revolving around it. This view dominated scientific thought for centuries until Nicolaus Copernicus proposed the heliocentric model, which placed the Sun at the center of the solar system.
strenuous, being a lifeguard, ever ready and ever alert, protecting us from floating too far and falling off the edge of the earth. The sea, you see, has a finality, the unpleasant consequence of which is a destination far beyond our reach. The world is flat, and that is that, as flat can be. The world is flat, and that is that, as far as your eye can see. Ask anyone who's fallen off, where they land is anyone's guess. We suspect it's hotter there than here, and staying here is best.
Yes, you read that correctly. Earth has zero measurable curvature. I've been researching flat Earth for more than 5 years, and have yet to find an inch of measurable Earth curvature. I know, with all the globe proofs and photos of Earth from space, but it's true, Earth has no measurable curvature. Don't believe it? Then follow along, and I will show you it is all about programming the minds of children, to more easily control them as adults. This means people like Carl Sagan, Bill Nye, Neil deGrasse Tyson, Michelle Thaler, NASA, the leaders of our countries, as well as the entire education system, is designed to indoctrinate children into believing a false reality. If Earth has zero measurable curvature, it means everything space-related has been a lie, taught to each and every one of us from early childhood. A definite crime against all of humanity. What is the one vital requirement needed, in order to have a spherical planet Earth, like the one we see in every alleged Earth photo from space? The answer is measurable curvature. Planet Earth has to have measurable curvature in order to match the perfectly round planet Earth. And why do these alleged photos from space have artifacts like this, when I play with graphic filters? It's because these images of Earth are created in a darkroom at NASA. Data visualizer and graphic designer Robert Simon, also known as Mr. Blue Marble, says, "It is photoshopped, but it has to be. Planet Earth has to have measurable curvature in order to match the perfectly round planet Earth." Think about this one undeniable fact. You can't have a spherical planet Earth without curvature. Zero measurable Earth curvature points directly to a level Earth, and tells us we've been lied to since the day we were born. You can verify this for yourself, by taking the time, to prove globe Earth has measurable curvature. When I am making observations over water, trying to measure Earth's alleged curvature, I use Earth curvature calculators to do the math. The math is simple if you have your camera at sea level, and it shows the number of the beast, 666. The math is, miles times 0.666, for example, 28 miles times 28 miles, times 0.666, equals 522.8 feet of alleged curvature. Here is that math using an Earth curvature calculator. Here you can see my eye level is 0 feet above sea level. The target I am observing is 328 feet high, and 28 miles away from my camera. Notice, with my camera at 0 feet, the horizon should start dropping away immediately. I use 28 miles in the example, because 28 miles is the distance to an island I see while walking Dennis Beach, New Brunswick. Let's put this math to work as I walk from 80 feet above sea level, down to 3 feet above sea level, and see how much curvature I can measure. The math tells us there should be 522 feet of Earth's alleged curvature blocking 100% of the 328-foot-high island, 100% of the time. Let's see just how accurate these calculators are. I will start at 80 feet above sea level, and then I will walk down from 80 feet to just 3 feet above sea level. Here are 3 alleged Earth from space photos. Notice that United States appears to be 3 different sizes. As a globe believer, how would you explain this? My camera is 85.5 feet above sea level. I am at Dennis Beach, New Brunswick, looking 28 miles to Isle Haute, which is 14 miles off Nova Scotia's coast. When I arrived at Dennis Beach, it was so hazy offshore, I had to stare for a few seconds to be sure I was seeing Isle Haute 28 miles out. I adjusted the gamma and contrast to decrease some of the haze so I can show you what I see. Isle Haute is 328 feet high in the center. There should be 185 feet of curvature blocking both points, which are below 90 feet. The point on the left is 90 feet high, and the point on the right is 60 feet high, where it drops off to the water. The fact we still see both points proves zero measurable curvature to the island from an 85.5 foot eye level looking 28 miles away. Now I will walk down the gorge, next to Dennis Beach parking, from 80 feet down to the beach at 20 feet above sea level, and see how long we can see the island. This is a steep hill, and today it's extremely slippery for the first 15 to 20 feet down, so please forgive the camera movement, and my complaining. Let's look a little closer at the 2 points. My eye level is 85.5 feet above sea level. There should be 185 feet of alleged curvature to Isle Haute. Note, the arrow is pointing to the 90-foot high point, but if you look closely you can see the top of the trees on the 60-foot point, at the lagoon. The point on the right drops off at about 60 feet above sea level. The red arrow is pointing at rocks 25 feet above sea level, which are blocked by high tide. Again, there should be 185 feet of curvature blocking the point and those rocks to the right of the point. I have just shown you there is zero measurable curvature from an 85.5 foot eye level looking 28 miles to Isle Haute.
Walk down here, down to the beach, 80 feet below, well 60 feet below, sorry, I'm at 80 feet, the beach is at 20. You can still see the points there. Let's see how far we can see the island. This is so slippery this morning. My eyes are at 80 feet now, 80 feet above sea level.
With my camera at 80 feet above sea level, there should now be 193 feet of curvature. Note that the bottom of the split is 225 feet above sea level, leaving just 32 feet below the split visible. Yet we can still see the points at less than 100 feet.
So many mosquitoes. Oh, this is really tough here this morning.
There is zero measurable curvature, from an 80-foot eye level, looking 28 miles. From a 70-foot eye level, there should now be 210 feet of alleged curvature. Yet again, there is zero measurable curvature, and we still see the 90-foot point.
60 feet.
Now my eye level is 60 feet, where we should encounter 228 feet of curvature. Remember, I told you the bottom of the split is 225 feet above sea level. We should see nothing below the split, yet we are seeing the entire island. Think about that. You cannot have a spherical planet if there is zero measurable curvature. It's time to start doing your own research. I now have a 50-foot eye level, which demands 250 feet of curvature. The top of the point, on the right side of the split, is 250 feet above sea level, meaning we should see nothing below the top of that point. Yet we still see the entire island. I am still dropping in elevation, I just can't see through or over the trees. I removed the audio, and sped up the video, until I get through the trees. I now have a 30-foot eye level, looking 28 miles. There should now be 300 feet of curvature, blocking all but 28 feet of the island. I want you to notice we can still see the top of the trees on the 90-foot point. Again, there is supposed to be 300 feet of alleged Earth curvature blocking that 90-foot high point, but it is not blocking those treetops. I keep repeating myself, but the fact is, there is zero measurable curvature on globe Earth. From an 85-foot eye level down to 30 feet there has been exactly 0 feet of measurable curvature. I am standing at 20 feet above sea level now, with a 25.5-foot eye level, where there should be 317 feet blocking all but 10 to 20 feet of the island. The thing is, the island is still quite visible. It's kind of like there is no measurable curvature at all. From my 20-foot eye level, looking 28 miles to the 328-foot high LOT, we should encounter 338 feet of the globe Earth's curvature, which should block the entire island. Yet there it is, not being blocked by globe Earth curvature.
Let's go down to the beach.
I like to turn my camera and focus way down the beaches to see what I can see. Things appear to get smaller the further they are away from us. They don't really get smaller, it's called angular size change. And the further they get the harder it becomes to resolve detail, until they eventually blend into their surroundings. In this case the lady and her dog are a quarter mile away, just over 1,500 feet. My camera is now 3 feet above sea level. There should be 446 feet of expected curvature, blocking 100% of the 328-foot high island. I was going to walk out to the sand, but the sea moss is wet and extremely slippery. Note, getting another 3 feet lower isn't going to magically make the island disappear. Zero measurable globe curvature leaves us with a level plane, not a planet. I have made this same observation more than 1,000 times, since learning Earth is not a spinning ball in an infinite vacuum, and not once, in my 5 years of researching, have I found an inch of measurable curvature. Saying the Earth is a spherical planet, in an infinite vacuum, without having your personal proofs on your channel, only shows you are still controlled by your childhood programming.
That's our show. Join us tomorrow night at 11. Here it is, your moment.
Afford to get some new teaching equipment.
Yes, my world map is so old it still shows the Earth is flat.